Hey everyone, welcome to Control Alt Do Leet. We'll be solving LeetCode problems to learn programming language. This series is for learning Rust. Today we are tackling a classic problem from Blind 75 list using Rust, valid parenthesis. Let's break down this problem. We are given a string S containing just these characters and we need to determine if the input string is valid. Here's what makes a string of parentheses valid. Every open parenthesis needs to be closed by the same type. The order matters. You can't close a bracket before you open it. Every closing bracket has to have a matching opening bracket and vice versa. No leftovers. Let's walk through the approach with a couple of examples. Consider this string. We use a stack for processing. We initiate the process by pushing the first character onto the stack. For each subsequent character before pushing it, we check if it forms a valid pair with the character at the top of the stack. If the current character is a closing bracket and matches the top of the stack, that is the corresponding opening bracket, we pop the top element. If it doesn't match or is an opening bracket, we push it to the stack. With this approach, a valid string will result in an empty stack upon completion. So to solve this problem, a dynamic or a fixed size array would be required to push and pop the elements. We can use vec in Rust, which is a growable heap allocated array that stores elements contiguously in memory, similar to array list in Java or a vector in C++. It automatically manages memory. It allocates, reallocates, and deallocates as needed. Push method adds an element to the end of the vec. Pop method removes and returns the last element of the vec. Let's go through the key nuances of Rust. When you push an element into a vec, it takes ownership of that element. So when you try to access this variable S after we push it to the vector, we'll get an error. When you pop an element, ownership is returned to the caller. Rust often infers the type of vector from the context, but when defining an empty vector, it may require explicit annotation. Rust prevents dangling references. A dangling reference arises when a reference or a pointer points to a memory that has been deallocated or is no longer valid. Rust's ownership system is designed to prevent such instances. For example, if we have a variable x with a value 100 declared on the stack, if we then attempt to push a reference of x into a vector, we'll receive an error. This error stems from the fact that the lifetime of x is shorter than that of a vector. When the cell execution finishes, x goes out of scope and the stack memory used to store x is invalidated. If vec outlives the scope of the cell, the reference inside vec would be a dangling reference, pointing to memory that no longer has a valid value. To correct this, we can do the following. Either declare x in an outer scope so that it lives as long as the vec, store values directly within the vector rather than references, only use references that have a static or a global lifetime. Since pop method returns option data type, we are forced to explicitly handle the case of an empty vec. Rust's match construct allows us to perform pattern matching and provides a clean way to manage different outcomes. Each arm of match has a pattern and the code will only execute if the pattern fits the value. Push and pop operations have O of 1 complexity. Inserting or removing elements in the middle of the vec has O of n complexity. Now let's solve valid parenthesis problem. We start by initializing the stack, and for each character in this string, if it's a closing bracket, we check if there is an opening bracket of that character at the top of the stack. If it doesn't, the string is invalid. After processing all the characters, if the stack is empty, all opening brackets had a matching closing brackets in the correct order, making the string valid. Otherwise, it's invalid. Now let's use match instead of if-else control flow. So the first three patterns are for opening parentheses. Each of these patterns will push the current characters onto the stack. That's straightforward. Now for each closing pattern, we check if it doesn't match with the opening pattern of that character at the top of the stack. And we return false. Finally, the catch-all is for invalid character altogether, so we return false. Thanks for watching. I hope you enjoyed the video. See you in the next one.